so that when we talk about the plan, you'll know where some of the context for the plan came from. So when the fuselage arrived for the airplane that later flew Flight 1282, the fuselage came in from our supplier, and when the fuselage came in, it was discovered upon load in the factory, initial load in the factory, that there were 5 non-conforming rivets. These non-conforming rivets in and of themselves did not create a safety hazard, but they were non-conforming and they needed to be fixed. So a defect arrived from our supplier. The airplane then traveled throughout the factory. You'll see the line with Katie in a little bit. It moved to the end of the line while we discussed with our supplier back and forth. Are the rivets okay? Are they not okay? Do they need to be fixed? Can you fix them this way? No, you can't. And the airplane was at the end of line by the time we all reached agreement that the rivets needed to be removed and replaced. At the end of line, we reached the point where we had what we believe is a non-compliance to our process. In order to remove and replace these rivets, the mid-exit door plug needed to be opened in order to get access to drill out the rivets, replace them, and we believe that plug was opened without the correct paperwork. You guys have read about it. It was referenced in the NTSB report, which is up there. So we believe there was a non-compliance to our processes at that point by having the plug opened without the correct documentation and paperwork. There was documentation and paperwork on the actual rivets. Those got removed and replaced. That was stamped off. That was appropriate. But by the time all of that got bought off and we were ready to go, the airplane was ready to move outside. We have a team that we call the move crew. Before an airplane rolls out of the factory on line move night, they come in and they just button the airplane up for the weather. They close the doors. In this case, they closed the plug. They ensure that any open holes on the airplane are covered so that it's in good condition to go out in the weather. We believe the move crew, we know the move crew closed the plug. They did not reinstall the retaining pins. That is not their job. Their job is to just close it and they count on existing paperwork. The paperwork goes with the airplane. All of the jobs are worked. Any open job gets worked later in the process. And in this case, because we believe the paperwork was never created, there was no open paperwork that traveled with the airplane. This actually is a photo of the actual airplane that you're looking at here. The last step is what we call an okay to close. And for an okay to close, typically people come in and look for really FOD, is everything clean, are we good to go? This was the picture that was taken during the okay to close. You can see 3 out of the 4 locations. We can see there are no pins in there. After that, we were given the okay to close. The blankets came down, and at that point, it was not visible. The plug has a little bit of an interference fit. That's how it was able to fly for roughly 150 cycles without being identified. That's how it passed our flight test, because it's a snug fit, but not a permanent fit. So that's what happened. A defect entered our system from our supply chain. The defect traveled throughout our final assembly, and then there was a lack of compliance to our processes by the correct documentation, using the correct documentation, and that's the background of what happened, and that will feed the rest of our system, and the rest of our processes and our proposal. Next chart, please. So step 1 is we immediately took steps. We sort of did this in a couple of phases. Our first phase was to take immediate action to ensure that no airplane ever leaves our factory that could cause an accident. I will tell you very transparently, the fact that one employee could not fill out one piece of paperwork in this condition and could result in an accident was shocking to all of us. We have a series of redundancies throughout our process, and we knew this could never happen again. We immediately had engineering do a review of our critical systems. And we identified what I'll call critical areas, things that could cause an accident. A rapid decompression, a major structural element that could come loose, critical flight control systems. We took a list of these systems and just immediately, out of an abundance of caution, put end-of-line inspections in place. Most of them were done after our first flight, before we went into our delivery process, where we went out and we inspected these critical areas just to make sure there was no other non-conformance in our system for anything critical. And we did this across all airplane programs. We are later in the plan that we go through, we'll tell you we're doing a much more systemic look, but this was an immediate action to ensure that there was no non-conformance that left our system. The other thing we did is we went out and we checked all airplanes here, we checked all airplanes in the fleet, and we do have confidence that no other airplane was delivered like this based on the complete fleet check that we did, the things we checked here at the airplane programs, but we want to make sure it never happens again. We also went out to all of our employees immediately. We implemented what we called a read and sign, which is just as it sounds like, to all production employees, manufacturing and quality. We put out a very clear statement that we said, here is the removal process in very clear language. Please read this removal process and sign that you fully understand it, to make sure everyone who has the potential to do a removal again really is reminded, you understand it, and we have 100% signature that everyone in this production system understands this process going forward. We did really a full review of this med-exit plug, and to ensure that any changes, anything that could be remotely unclear, we started at Spirit, we worked it all the way through our system, any documentation that needed to be clarified, any confusing parts, anything any employee said, well, I wasn't really sure what this meant, cleaned it up, clarified it, went back out, made sure that everything in that process is crystal clear. We also looked at other what we call like areas, particularly doors. Let's go back and look at all of our doors. Is there any chance anything like this could happen on any other like structure? Did full inspections just to make sure we really had our arms around it, talked to our customers, took best practices, and did all of that immediately. And so this was sort of our immediate answer to the question, how can you be totally sure that the airplanes you're delivering today are safe? We did a lot, we did it quickly, and we are confident in that answer. Next chart, please. So then we said, but this is our moment. This is our moment to step back and holistically look at and be very introspective. What else could we do? How can we be certain that our system is as absolutely robust as possible? So we started collecting input from many, many sources. First and foremost, our employees. We implemented what we named quality stand-downs. We've done them at every major manufacturing site in Boeing commercial airplanes. We did them at 20 locations, where we stepped back and we invited big cross-functional groups of employees. Engineering, manufacturing, supply chain, quality, finance, HR, you name it, they came together. And through these quality stand-downs, and there's a couple of pictures of them there, we've had over 70,000 employees in Boeing commercial airplanes go through these quality stand-downs. And the quality stand-down was organized where we brought all of the employees together in the morning. And we sort of got them all together and said, why is this important? What's going on? And had a conversation with leadership. We then went to the manufacturing areas, and we had people work with the teams they work with. For example, the landing gear team. We had the people who buy the landing gear, design the landing gear, install the landing gear, work in service on the landing gear. Everybody come together and work together as this cross-functional team around the area they work with. And we did this through the whole airplane program. We then took everyone to the manufacturing floor, and for those who aren't there frequently, we taught them. For those who are there frequently, we participated in a safety walk and a compliance walk. Here's what we look for. Here's how the factory really runs if you don't live in this environment. Here's exactly how we do it. And then we provided this team with a list of defects that they had created or that we discovered in the field or anything that had potentially been a defect on their commodity. And we turned them over to this team and we said, please provide us with ideas, on thoughts, on how we make a defect-free product.